Hello, students. So, just to refresh our memory, the Fibonacci numbers are the numbers that are defined by setting, the first two are both 1, and then from then on you just take the sum of the two previous numbers. So 1 plus 1 is 2, and 1 plus 2 is 3, and 2 plus 3 is 5, and so on. And we know how to find the Fibonacci numbers recursively. I mean, we could even, it's so quick to code, what we could do is we could just make a little Fibonacci program right here, recursive. I'll emphasize that this is going to be our sort of our functional approach here. So what are we going to do? Well, we're going to return 1 if, so fib 1 and fib 2 are both going to be 1. So I could do this. There's a lot of ways I could do it. I could also do n less than 3 because we're assuming that, the people running this are in good faith. They're not just trying to make it crash. They're not going to give it something weird. Okay, so we're going to return 1 if n is 1 or 2, and then otherwise, we're going to return fib rec n minus 1 plus fib rec n minus 2. And now let's try this. Let's try it for an example. As a matter of fact, if we want a more robust situation, let's do this. For I in range, let's get and we started at 1, so let's not try to give it fib 0. We don't want to run into trouble there. And you see we're getting the Fibonacci sequence again, 1, 1, 2, 3, 5, 8, 13. Now, there is an issue here with doing this, and that is you actually end up calling on yourself a lot. What do I mean by that? I mean, let's say you wanted to get fib rec 4. Well, to get fib rec 4, you need fib rec 3 and fib rec 2. And to get fib rec 3, you need fib rec 2 and fib rec 1. So it's going to compute fib rec 2 twice, right there. And this problem is going to get much, much worse as, n gets larger and larger. Because to get fib rec 100, you need fib rec 99 and 98. But in order to do 99, you need 98 and 97. So we're going to get 98 twice. But in order to get 98, we're also going to have to get 97. So the problem is going to get worse and worse. We're going to be computing things lots and lots and lots of times. So it's not too efficient. Now there's a way around this called caching. But I don't want to introduce that just yet. I want to talk about another way we can do this, a completely different way. So let's try to do this without recursion. Let's just try to teach Python how we could find these Fibonacci numbers from scratch. Okay, so let's do this. So we could say, okay, Python, let's start with 1 and 1, right? 1 and 1 are the first two Fibonacci numbers. And then in order to get the next Fibonacci number, what would we have to do? Well, to get the next Fibonacci number, we'd have to add 1 and 1. So let's think about that. Let's just naively start off with an a equal to 1 and b equal to 1. And then let's just say, for I in range n. And what we're going to do here now is we're going to say, okay, we're starting with 1 and 1. Now, the next one's going to be 2, but I need to store 2 Fibonacci numbers at any given point in time because I'm going to need to keep adding the last 2, right? In order to get the next Fibonacci number, 2, I need 1 and 1. But in order to get the next Fibonacci after that, I'm going to need 1 and 2. And then I'm going to need 2 and 3. And then I'm going to need 3 and 5. So I have to store 2 Fibonacci numbers as I move forward each time. So what am I going to do? Well, I have a and b are 1 and 1. So one thing that I could do is I could say, okay, let b be the sum of a plus b. But now I have a problem. You see, I have to think about the order in which I do things, right? Because I could let, c be a plus b, and then I could let a be b, and then I could let b be c. And that's actually not a horrendous way to do that. I want to shift over to the next 2 Fibonacci numbers. So from 1, 1, I want to go over to 1, 2, then I want to go over to 2, 3, and then I want to go over to 3, 5. Let's leave it like this just for now. And then when I'm done doing this, so this is going to do this over and over again for all I in range n. And then at the end, I want it to just return NB. Now, I'm actually not sure what number this is going to give me perfectly. Let's see, fib1, and of course, so fib1 is 2. So we don't want this to happen at all if we're starting off with a equals 1 and b equals 1. So what's happening is when I give it 1, it's doing this step once, right? I don't want it to do that once. So let's change this. Let's do this n minus 1, and now let's see if we fix the issue. So now I get fib1 equals 1, but I'm going to get fib2 equals 2, which I also don't want. So let's do that. Let's bring this down even further. Another thing I could do is I could also ask it to return A instead of B. I could do that. That should work. So fib2 is 1, now fib3 is 2, fib4 is 3, and so on. Fib5 is 5. So this is doing good. This is going to give me the exact same sequence. Let's just show that is correct. And I get the same numbers here. So what am I doing? I'm storing the numbers 1 and 1, and then each time what I'm doing is I'm computing the sum of these two, so 1 and 1 is 2, and then instead of storing 1 and 1, I now store 1 and 2. Now this is a very, very imperative way of going about it. I'm teaching Python my system, this system here, for finding the Fibonacci numbers. So it's a nice example of code that runs pretty fast in an imperative style. We can get rid of that C though. We don't need it. There's something that we can do in Python. We can instantly replace A and B using a tuple. If you do this, A and B, I want to replace A has to become B, and B has to become A plus B. You could think of this exchange as happening simultaneously. It's not, it does one first and then the other. So let's just do that to show you that this is still working. And as you see, it works just fine. So when you're using tuples like this in an assignment, what this is just doing is it's setting the first thing to the first thing, the second thing to the second thing, and so on and so forth. Yeah, that gets rid of a line. As a matter of fact, if you wanted to, you could do something like AB equals 1, 1 over here, but shorter is not necessarily better. But this will work too. As you see, we get the same result. So this is actually going to end up running a lot faster than this. There is a way around that using something called caching. But like I said, we'll get to that later.